Hi, I'm Sean Gannon, and this is Minute Math. And I have a question for you. We got two shapes here, and we gotta determine which one of the inner region areas is larger. Our shapes have identical semicircles, okay? Same semicircle here, whatever the measurements are. The left shape here, the one that's in pink, each one of these are identical squares, not drawn at the scale, but use your imagination. And they're inscribed within this semicircle. Same with this square. This is one big square and it's inscribed in that semicircle as well. So I want you to vote and see which one you think has the larger area, the pink or the blue one, and let me know down in the comment section below. All right, let's go solve this problem. First one here, let's deal with our pink semicircle. Let's give it a center point. Let's call it C here. And one thing we know about this is to this point right there, we can say that this line here is equal to the radius. Let's call it R. And I label this point, let's call that point P, P, not B. And this point down here, let's call A. We have C, P, A, and we make that a right angle right there because it's a square down there. And what do we notice? We have a right triangle going on. Now, if I label each one of the side lengths of these little squares equal to X, as such, we can go through all of them here, right? You get the gist, there's a lot of them. So we got a right triangle, we got some values, well, variables. What can we do with it? Let's think Pythagoras. A squared plus B squared equals C squared. Our A, let's call the base down here. X plus X is a 2X, so we have a 2X all squared plus our B value, let's call it X squared, just that value, is equal to our radius squared. From there, let's go simplify. 2x all squared is a 4x squared plus an x squared equals an r squared, and 4x squared plus an x squared is equal to a 5x squared, and that's equal to an r squared. Well, if I divide 5 to both sides, I have x squared is equal to r squared over 5. And what do we know as, well, the value of x squared? In this case, the value of x squared is equal to the area of each one of these smaller squares, right? Like side length times the side length, side squared, x squared. So our area of this figure is going to be 4, we have 4 of those squares, times x squared, or in terms of our radius, which is going to apply to that one, a r squared over 5. And so that is a, well, 4r squared over 5 units squared is that area here of our pink, well, squares. So let's go solve the second one now. Again, we have a semicircle, let's call that C. Let's get some values. I'm gonna call this one here, let's do something different, let's call it B. And instead of P, let's call it O, CBO. All right, connect these lines here, we got a radius. Right? We know it's going to be a right angle right here. It's a square on the inside, right angle right there. And what am I going to make the side length here of our square? I'm going to call it 2x. And the reason why I'm going to do that, that means C is the midpoint in this square. So this little length here is going to be just an x of CB, and this is a 2x. Again, good old Pythagoras can help us out here. We have an x squared, that base, plus a 2x all squared is equal to our radius squared, hypotenuse squared. X squared plus 2x squared is a 4x squared equals an r squared. From there, add together, we have 5x squared equal to r squared. And x squared is equal to a, r squared over a 5. Well, how does that apply to this square here? Well, our side length here is a 2x, right? Side length is a 2x. So we have that x squared is equal to r squared. From the area of this big little square here, big little square, is going to be a 2x all squared. Well, 2x all squared is a 4x squared, and we've already said x squared is equal to r squared over 5. So our area here is 4 times an r squared over 5, which should look familiar, and I'll put it up here because I just like to do that. And our area here is going to be 4r squared over 5 units squared. And hopefully you see that they're the same. Again, another trick question here. These two shapes share the same area. And maybe you knew that, and way to go. And if you didn't, well, hope you had some fun finding that out. Hope you liked this video, and if you did, like this video, subscribe to our YouTube channel. This helps us make more of these fun math videos for you and for everyone else. So, as always here, thanks for watching.